Hello, everybody. It's great to be here one more time today. My name is Gary Fowler. I'm the CEO, president, founder of GSD, Get You Done Venture Studios, a premier AI and quantum venture studio located in the heart of Silicon Valley. I'm a 17-time serial entrepreneur with several unicorns under the belt. I was on the original management team of Click Software, which was sold to Salesforce for $1.35 billion, and also Eva.ai, an AI HR tech company that I co-founded with Dr. David Yang. We believe at GSD that intellectual capacity is evenly spread around the world, but opportunities are not. GSD is a family office. It is a scaler, a PR group, and we also have frontier AI development. We have things like multi-agent, multimodal LLMs. We've created a complete 360-degree ecosystem. So with that, I'd like to bring our incredible guest on today. We're going to be talking about ending GPU vendor lock-in, true CUDA portability for the AI era. In today's AI economy, compute is destiny, but far too many teams, the destiny is constrained by hardware lock-in. CUDA unlocked an entire generation of accelerated computing, but also tied innovation to a single vendor ecosystem. As AI workloads explode and GPU supply, cost, and geopolitical risk intensify, the question is no longer how fast can we scale? It's who controls our ability to scale. That's why I'm excited to welcome Michael to my show today. He's the founder of Spectral Compute. He's a computer scientist who spent over a decade deep in the trenches of software engineering and accelerated workload optimization. In 2018, while helping teams push performance limits, he and his team kept hitting the same wall. GPU vendor lock-in was slowing innovation, infiltrating costs, and restricting architectural freedom. That insight led to the creation of Scale, a breakthrough solution that enables CUDA workloads to run seamlessly across both NVIDIA and AMD GPUs. In 2025, Michael raised $6 million in seed funding to scale this vision about a truly hardware-agnostic future for AI. In this episode, we'll explore what true CUDA portability means, why GPU lock-in is becoming an existential risk for AI builders, and how the next generation of compute infrastructure will be defined by flexibility and not dependencies. With that, I'd like to bring Michael on board. Hi, Michael.
Hi, Gary. Thanks for having me.
Yeah, so it's interesting. I've known Jensen from NVIDIA for a long time. In fact, I've been over to his office for lunch, actually. And, I remember when he got started in this, about 93, actually, got involved in building PC boards. And, look what's happened since then. But, Michael, let's start with the problem itself. Why has GPU vendor lock-in become such a critical issue now in the AI era? And how do we fix it?
Yeah, so leaning into what you said there, Jensen really set the stage for where we're at, right? CUDA is an amazing toolkit, and because of its greatness, people have built a huge ecosystem of software, simulation, workloads, any kind that actually precedes the AI revolution that only really started a couple of years ago. Even though it seems like we've been at it for a while, actually the greatness of CUDA stems all the way back from the original launch in 2006. And it's been built upon ever since, and it goes beyond AI into all kinds of simulation tasks and engineering classical workloads with finite element analysis, computational fluid dynamics, all these types of mission critical, really, workloads that people are relying on for loads of different commercial tasks. And why is it so critical now? Well, I was going to say it's no more critical now than ever, right? Everybody wants freedom to pick the best solution for their situation, and there are a lot of factors to consider there. One is supply chain constraints, right? NVIDIA or any single company can't necessarily scale up production to cover the whole globe at once. And so people are going to be regionally, geographically excluded from vendors just by no fault of their own, so to speak. And that's one aspect of it. And it's as true today as it was also 10 years ago when AI wasn't the leading workload that is driving demand.
It's interesting. I've been working in expert systems for 30 years. I've been working in AI. So I started one of the first generative AI companies, pre-transformer models, in 2016. That company was called Findo, then Eva, your virtual assistant. And people said it was never going to happen. And people don't understand the incredible amount of energy the systems use, the incredible amount of power that's needed, and how much it's going to change our planet. But with that, Michael, CUDA has been incredibly powerful. But where does it start to become a constraint rather than enabler?
Well, so only to the extent that when people first go about writing some kind of program to take advantage of accelerated computing, GPUs in particular, right? They engage in a different programming model. Programming GPUs is a new type of software development compared to programming CPUs. And this is a parallel I want to draw upon as well, because we can compare with the realm of the CPUs today, where you have the freedom of choice between loads of different vendors and loads of different architectures. And without significant work as a software developer, you can freely take advantage of an ARM CPU, an AMD CPU, or an Intel CPU. And some of them have different hardware features that you can take advantage of still from a single source code base. And the only reason this is true is that there have been an investment in compilers from companies, software developers, and the open source community to make this possible. And nobody's really done that for CUDA because, well, in part, nobody's really been incentivized to do it. So I don't see CUDA as a blocker. I see it still as a continuing enabler of future innovation, as long as somebody undertakes the work to also make it compatible on different hardware, sometimes with performance trade-offs, sometimes with better performance for certain types of operations. But the key to start with is compatibility. It's got to be possible to just take the source code of a program, some accelerated computing thing, be it the latest and greatest AI model, or some other simulation workload that you've made, and try it out on a chip. Then, you can go from there and do all sorts of things with performance optimization for that particular chip. But if it doesn't work out the box, we find that most people don't even want to try.
For founders and CTOs who haven't felt the pain yet, what early warning signs tell you you're headed towards this dangerous dependency?
Well, when prices go to a point where you really don't know what your total cost of ownership is going to be like over a 5-year period, and with these refresh cycles where there's constant pressure to upgrade every year, even though there isn't necessarily signal value from your consumers to do so, then that's what I would be looking for. And I think overall, more competition, the solution to this is, of course, more competition, more enablement for a variety of different hardwares targeting different performance levels and different pricing levels as well.
Take us back to 2018. What were you seeing in real world workload optimization that made you realize this wasn't just an inconvenience, but rather a systemic problem?
Yeah, well, we were building a computer vision toolkit to do real-time object detection and redaction for videos. It's called redactor.com. It was with a prior startup called Sighthound. Still exists to this day. And we had written all that in CUDA because it was the most easy-to-use toolkit for it. And it had a lot of accelerated features for us to just plug into and take advantage of. But then we realized, well, actually the prevailing solution for making this work on AMD back at the time didn't work out the box. So we tried just as software developers to make that transition and actually put in the work and effort to see if it could run on what are otherwise very comparable GPUs, right? We saw the price point advantage that AMD had on the consumer side back in 2018, and we really wanted to make use of that compute per watt efficiency that was enabled. But the hurdle was just too big. It was too much work to make it such that we could even run on AMD in the first place. And then even after we had put in that work to run through the source translation tooling that exists, it's something called Hipify, then we were left with the problem that now, in order to retain the ability to also run on NVIDIA, we needed to maintain two pretty much identical code bases doing the same thing. And then imagine wanting to add a third vendor, an extra GPU manufacturer such as perhaps Intel or Apple GPU or anyone else making similarly capable hardware. Well, that problem compounds and becomes exponentially more difficult as a software developer to maintain. So that was really the key insight that drove us into, well, clearly other people in the industry must be having this issue, and well, that's been very much validated on our journey since.
You know, what's the hardest technical assumption you had to scale when you challenge you had when you were building scale?
Well, there's a bunch. So the hardware is not the same. There's a bunch of differences between AMD's architectural choices and NVIDIA's ones, but this is actually also true within NVIDIA's own GPU product lineup. So if you compare the hardware features and the architecture of a Volta GPU from around that era that we just talked about to the modern Blackwell ones, well, at the transistor level, they actually look nothing alike. And they have way different feature sets. And the Blackwell one is, of course, way more advanced. And so this problem exists even within one vendor of architectural, newer architectures of GPUs, right? So the work really lies within acknowledging that, realizing that, and teaching the compiler. We can get very arcane and very deep into compiler theory. I'll try and keep it high level, but teaching the compiler how to deal with those differences, be it within a single vendor or between vendors. And as it turns out, actually a lot of that work informs and guides optimizations that scale across vendors as well as between in individual generation. So some of the optimizations we're doing benefit both a Volta and a Blackwell GPU on NVIDIA, and equally for some of AMD's GPUs, there exist hardware features that we can teach the compiler to take advantage of, even though the CUDA program itself didn't know about the hardware feature and doesn't have to, because the compiler code gen is what makes that a reality. But this is all really hardcore tech. This is not easy to do. We're talking about translating high-level abstract programming into very concrete instructions to a massively parallel machine that has thousands and thousands of cores, all trying to do a parallel dance about how to most efficiently move bits from memory, one piece of memory, transmute them, and then back into another piece of memory or to another GPU or to the network or something like that. It's very complicated.
You know, what changes for an AI team once they're no longer tied to, you know, and this is the problem for everything, right? You're now giving people the freedom, so they're not tied to a single GPU, in fact, but that's not what, you know, companies like NVIDIA or AMD want. Obviously, they want you tied into them. What does that do for you? And do they support you, or are they become your best friend or your worst enemy?
The vendors, so they have an interest in us succeeding just as much as we have an interest in them succeeding. We're positioning ourselves as a neutral party, befriending all of the chip vendors that we can. And we see it as providing for each and every individual vendor, right? We provide the optionality for people who otherwise wouldn't buy their hardware to enter with a separate swim lane to their own software stack, their ecosystem. So think about it like marrying the best parts of AMD software ecosystem with NVIDIA's ecosystem. Through us, you get the choice and the optionality, and that's a benefit to both NVIDIA and AMD, because that puts people, it empowers them to switch back and forth, right? As we've had in the CPU industry for many years, the freedom to switch between AMD and Intel, and they can compete on the merits of what is the latest and greatest right now. For GPUs, it's a little bit more complicated, right? Because it's not just about the highest boost clock available or the highest performance metrics. It's also about VRAM size and what kinds of models and other hardware accelerator features exist. And so this benefits the whole ecosystem, but for the chip vendors in particular, right, they get a higher addressable market with software that wouldn't otherwise run on their chip, but also the option to target a niche with, let's say, a particular SKU that NVIDIA didn't segment for, right? AMD could say, well, we're going to do, or AMD or any other vendor in theory, right? What we're talking about here is solving this problem for the whole industry in the long run, not just AMD, just to make that clear. But it allows any in particular chip vendor to target a niche segment and say, we're going to do HBM3 in this particular quantity to target these exact workloads. And people don't have to change their software. It just runs, right?
Well, I mean, I see that, on the AI side, using multi-agent models that are, whether Perplexity or Anthropic working together as a team. And we've done that. This is going to, because the other thing is there's certain technical specifications that one vendor may have that another one doesn't. For instance, one of them, LLMs, is 1,000 times better mathematical capabilities than another one. Now, if you create a team and they reallocate those jobs to that particular LLM that has those power, it helps everything. It changes the game. Plus, they cross-check each other. Who's right and who's wrong. It's like when you get in a group and you're talking about something and you make a mistake, it corrects you. The other members of the group say, listen, this isn't right, Michael. This is the way it is. And that freedom and that ability is going to help us to be able to solve things at a speed that we've never been able to understand before. And especially now with quantum computers, right, which can be 100 million times faster than the fastest supercomputer. It means what would take 10,000 years now takes us 200 seconds, by the way, real statistics. So what, let's look at it. So the GPU portability changes the economics of AI, especially for startups and scale-ups, right? So what does this unlock for cloud providers, hyperscalers, or sovereign AI initiatives? What does it do for them to help make them better?
Well, for cloud service providers and sovereign AI initiatives, it means overall a lower total cost of ownership, right, for operating the data center, because you get the choice and you're not restricted to a single supply chain. At any moment in time throughout 2026, right, there are going to be different pressures on different suppliers at any given time, depending on what the status of the market is. And so being allowed to freely pick between all of them is a huge help for lowering the total cost of ownership. But in other situations, right, time is of the essence, and it's about getting all the compute you can as quickly as possible. And this also helps because that might not be the topmost vendor at any given point. So just the freedom aspect of being able to run the same workloads, right, without having to tweak them when you then choose to go for a big tender with one of the providers beforehand, just decoupling those decision points is a huge factor.
So how do you see NVIDIA, AMD, and emerging accelerators responding to this shift?
I see them embracing it. I see a future where everybody is acknowledging that there's no prior attempts at creating a single compute standard have so far not solved this problem. And we're going out there to prove it that, well, we can. It just requires agreeing on a de facto standard as opposed to a standards body driven approach, which is what we're sort of moving away from. There have been prior attempts, right, with OpenCL, but it hasn't gained any adoption compared to CUDA. And so we're saying that this approach can scale and work.
No, I love it. So do you believe the future of AI compute is fully hardware agnostic, or will hybrid dependency remain?
I see hybridity being a huge aspect of it. You mentioned quantum computers. I see quantum compute as excellent for certain use cases, and it can be an augmenting new form of compute that people will want to add into their clusters. But it won't replace all workloads, and certainly transformers, I don't see them running on quantum computers as a whole concept anytime soon. But there are lots of classical workloads as well where you can't really run those meaningfully on a quantum computer. So you want hybrid compute consisting of a lot of different kinds of accelerator types, and also lots of different vendors, because no single company can build all that different type of transistor design, right? That just goes to speaks for itself, right? It's too complex for any single company to encompass all of that. So you'll see TPU-like architectures, systolic arrays. You'll see GPUs, XPUs, as they're called in general, GPU-like architectures, right? As well as lots of CPU compute and novel compute types like quantum. And de facto standards are what's going to bring it all together. And CUDA-compatibility is just, well, a state of fact. It's something everybody needs to acknowledge as necessary to move on.
You know what?
And it's in everyone's it's also in everyone's ultimate benefit, including NVIDIA themselves. If you think about it, changing away from the de facto standard and migrating workloads away to, let's say, SYCL, that's an open standard, attempting to compete with CUDA, or any number of other new programming languages trying to do this. Well, that's a net negative for NVIDIA, and also a net negative for the ecosystem as a whole, because that fragmentation just becomes worse, right? Then you've got to know, as a developer, as a software engineer, or an AI researcher, more different algorithms, more different programming languages, loads more material in order to achieve what's otherwise the same research.
So, let's think about it. So AI leaders today need to look at making some architectural decisions to be able to stay flexible, or they're going to be out of business, quite frankly, in the next 5 to 10 years. What kind of decisions do they need to make?
Well, towards hybridity and flexibility is what I would say. Standards-based interconnect to connect these different kinds of compute engines, chips, whatever you like to call them, nodes. And then at the software layer, well, de facto standardization around CUDA. And we're going to be one of those independent vendors that move ahead that de facto standard and hopefully entice the rest of the ecosystem to come along with us.
What's the biggest misconception people have about breaking free from GPU lock-in?
It's that programming language is inherently designed for one chip. Like, there's a common misconception that, well, it's impossible to do what we're doing. But in reality, it's been done in the realm of CPU programming for the better part of a century at this point. Grace Hopper was the original author of a compiler ever since she
I remember meeting her. I met Grace Hopper, by the way. She did COBOL. Yeah. I remember she was an admiral and one of the guys that I met. And so it was interesting. We were at, I think it was at Brown University, and she came in, and Ken Olson was a guy who founded a company called DEC. You probably read about those in PDPs, some of the first scientific computers, but I was there. And I remember getting a chance to meet her, and it was quite interesting, right? So this language becomes a language of business for a long time, actually. And, we're
still
just
to this day, COBOL is in critical infrastructure, still being used to this day. You probably couldn't use a MasterCard or a Visa. Yeah.
Got it. No, I agree. And I was there, I remember, because I sold, when at that point in time, I took a few years off of doing startups, and I was working for Digital Equipment Corporation, and I sold 2 of the largest systems they'd ever made, actually, the VAX 9000s. I remember in those meetings, I remember meeting her, and this lady was unassuming, by the way. She didn't seem like who she was, right? Although she was an admiral. Anyhow, so Michael, as a founder what did raising $6 million in seed funding enable you to do that you weren't able to do it before?
So what we're doing is a massive engineering undertaking. We're not done reaching full compatibility with CUDA. There's more work left to do. We're a long part of the way there, and many of the toughest technical challenges are behind us. There's an increasing amount of work that we could see in the future that's still interesting to do, right? And it's all engineering. It comes back to what I was talking about with the compiler and how hardcore challenging this work is. The talent pool globally for doing this kind of compiler work is very, very small. Not only do you have to be a compiler expert to do what we're doing, you also have to be familiar intimately with these GPU instruction architectures. And so actually sourcing this talent and teaching these people how to do it is our growth challenge, and that's what the funding is mainly for. In addition to, of course, commercial go-to-market scaling, but the driver or the main gist of it is further expansion of the engineering team.
You know, we had one of the companies, I got introduced to a company called IET, Intelligent Electronics. The company was from Haifa, Israel, and a guy named Fred Harmon introduced me to the company. And they were brilliant engineers, right, and brilliant physicists. But in terms of turning it into something that was commercially interesting and exciting. So I changed the name of the company to Click Software, came up with a family of products: Quick Plan, Quick Fix, Quick Analyze, Quick Schedule, Quick Forecast. People said, I heard of the company. Same thing, right? We broke one product into several, 5 products, and all of a sudden it became sexy and enchanting and exciting. And people started grabbing out of the hands. And sometimes we forget that, you know, guys like Jensen, right? They know how to make things exciting, and it's critically important if you want to build a unicorn, and I've done it a couple of times, to do it, especially in Silicon Valley, because they're looking for that magic, right? And you're changing the world. It's not just about building a compiler. It's going to change everything from efficiencies and things like energy, right? It's because when you're using the right product at the right place at the right time, the efficiencies go up. One is energy optimization. The other thing is compute at an entirely different level. People don't get it. Plus, there's freedom. There's freedom to use the hardware that you need to be able to get the job done. That's
Definitely
amazing. So anyhow, when we're done with the show, if you want to stay on for a few minutes and talk, I've got some time. If you get a few minutes, it'd be great to talk to you. So finally, if you could give one piece of advice to AI builders designing their computer stack today, what would it be?
Just keep doing what they're doing. Use the cutting edge CUDA toolkit that already exists, is already the standard. Lean into Qtile, the latest developments from NVIDIA, because they're doing great work and they've been enabling innovation in the AI scene since before AI was incepted, the modern AI that we know, right? So,
I mean, FYI, when we did our company in 2016, I called Jensen up and I got him on the line. So I think it was Mary was his assistant at the time. And I got him on the line and we were talking about things then, right? 2016, 2017, because I started one of the first generative AI companies, and his vision is so amazing, right? And look where we are today, but your vision is amazing too. It's not about where we are, it's about where we're going to go, isn't it?
It definitely is, yeah. And a lot of exciting stuff is happening. I'm really excited to see what comes out of 2026. I think it's a different landscape, different future from where we were last year, but in all exciting axes is exciting in all axes is what I meant to say.
Exactly. Listen, I want to thank you for taking time out of your busy schedule to join me today. And I want to thank all of you for joining one more time. And thanks to all of you, this is our little over 1,500th podcast all over the world. Today, we're in 73 countries. We have 180 companies inside of AI companies inside of my family office. And it's all because of you. The key is we want to get stuff done. The name of the company is GSD for a reason, to get shit done. It's not about the talk, it's about the action. Stay happy, stay safe, and stay healthy. We'll be back to you again soon with another exciting edition of Top Global Startups by GSD Presents. Thank you. And we'll stay online after we're done.
Thank you.